an old Ampeg combo from early 60s for service. I think it's a Jet J-12T, meaning tremolo. They did a reverb version, but this unfortunately is not the reverb version. Nice and small, still original covering, handle gone, original chrome plate, original chicken head knobs, everything looking nice. Grill's even quite nice. Now this is supposed to be a 12-inch speaker, I believe. It's a nice size, nice and deep, just like this one, to get not too boxy sound. So let's have a look at it, see what we've got to do to it to fix it. Now here's the back. It's got a nice space here where you can see the valves for easy access if you wanted to change them. Hopefully you don't have to change them too often. Probably not the original valve, who knows. Lovely little short ones there, really nice looking. Look, and there's the back of the speaker there, and it's got a sticker still on it, which I think, I can't quite read it, I think it says custom or something. Anyway, it's a little sort of horseshoe style Alnico magnet, so it should be quite nice. Now the back has screws on it normally, but this one, the screws have been taken out, so we can open it up and swing it out. A couple of things to notice. Just have a look at the back panel. Bit of heat reflecting, and its circuit diagram is stuck on the back. They don't do that anymore. Helps with servicing. It's a bit faded and worn away. It gives you the name and the numbers of the valves. Looking inside, it's a 110 volt version. They never made 240 volts, so if you're going to run it off 240 volts, you're going to need a hefty transformer. I recommend at least a 100 watt. Inside, going to see what we're going to have to do. Most of these components look original. Not sure about the ones in the tremolo. They look a bit modern to me, so someone might have changed something. Resistors, you know, no obvious damage. Big high watt resistors there. I need to look at the drawing to see what's missing. Nothing seems to be broken. Cables, so it probably just needs cleaning up. Some of these capacitors, check them over, clean the pots, clean it up, check the valves, see if we can make it nice. Massive filter capacitor here, really long. Might have to change that. It's probably got multi-sections in it. You can see the speaker. It's supposed to be a 12-inch, but it looks slightly smaller than 12-inch to me. It's original though. Before I turn it on, I'll check the valves, check some of these components. Bit of noise coming through from bit of a bad connection on that valve. So we can just check out the valves, the contacts. Now the tremolo, stopped working now. So I think we got a bad connection here somewhere. The tremolo does thump badly. I don't know if that can be cured, but you can hear it. Works. The speed goes from slow to fast. Oh, it's getting a bit noisy now. And off. So it's just a matter of sorting out the contacts on these valves and checking the voltages and getting rid of some of this noise. I've taken the amp out of the cabinet so you can see inside and look at the speaker. It's still got the original sticker on it, Ampeg custom design it says. Sometimes there's some printing on here with the date and everything, but that's not on there at all. I'm not sure if there is a label around there, and it looks like it's been reconed. This looks like a new cone. There's some codes written on the side. I don't know how to interpret those, whether they give you an idea of the date. On the side, you've got stuck on stickers. So looking at them right now, a model J12, serial number 005503, which is the same as the number that's actually etched onto the front panel. And here is, it says model number J12-A here, no serial. Valves 6BK11 7591 by 3, and in very, very faint writing underneath, you probably just can't see that, someone's written in pencil 6C10. So Ampeg obviously suggested that that's other alternative valve 6C10 was quite okay to be used in this amp. Now looking at the back panel, there's a clue to when this amp was made, because on this circuit diagram, which also lists the 6C10, here 265, that is the date when this circuit diagram was drawn out, so February 65, so it couldn't have been made before February 65. Other clues to when this amp was made is on the components, which will be in the amplifier over here, and normally you can find a date on the capacitor, but this one, there's some writing around the bottom here, but no, 115, and it says 8 or 92, something's a bit rubbed off. There's nothing else on that. These capacitors in here, no date codes on them, unfortunately, though they're all original except for these. Someone's changed the tremolo ones, but you can get a date off of the CTS pots. They've got codes on the back, and online you can find, someone always tells you how to work out the code. Here they tell you this code means 64, so I wrote down the code off ours, 1376442, which means 1964, week 42, end of 64, those pots were made, and that's the circuit diagram said Feb 65. We know it was made about the beginning of 65. The amp itself, which I have here, you see they went to all the trouble of chromium plating the whole chassis, but you only ever see this top part, which is obviously corroded and dirty. I don't think I'm going to clean that off in case it cleans the remainder of the lettering off. Model J12. A couple of things to look at. Original transformers. This one's quite interesting. PT106, number 682A51. This one says 682-504 OT-151, which I'm assuming is output transformer. Probably could have meant 15 ohms, one output winding. PT106 682-451 original. Speaker connections, original wires. Okay, let's have a look. It's very shiny. The valves. Some of these amps don't have rectifier valves, they're solid state. This big capacitor, I think, is original. Let's turn it over. The valve sockets. This valve socket, when you move the valve, it crackled like hell, so I've got to check the tension of the little sockets with a little tool, just to make sure they grip. And then I'll check all the components. I've got a very useful tool for testing the capacitance, the ESR, and the actual capacitance. If the ESR is unusually high or capacitance way off, then it needs changing. You can check. I can check all these capacitors in here. I normally find these ones are fine. A lot of people change them, so you've got to change capacitors, but I find that these capacitors often, they might have drifted out a bit, but they still work fine, unless there's some unusual noise or something not right. I'm not going to change any components in here. The big one, even this, everyone seems to say, oh, you've got to change that, but if it's not humming or or just no power or something, or I think there's something wrong, I'll change it. But otherwise, this is a multi-section. It's got 3 capacitors in there. You can't really buy these anymore, and it's just a mess to take it off and put modern capacitors in. So hopefully that's going to be fine. Back of the transformer, bulb, components, can clean up these with some switch cleaner. The big power resistors, they look good, not even burnt. And there is another resistor down there, I can check on there. Sometimes those sort of resistors get hot. They doesn't look burnt though, but there's a carbon composition. They really can drift a long way out over time with heat. Everything else is looking pretty good in here, but I am going to test components. I can test them with the normal resistance meter or a more sophisticated meter if I need to. This is called the death cap. It's connected from the mains to earth, so if it blows out it can be a problem. This one hasn't. The 2 wire comes in to the fuse, not earthed. There's been a bit of, it's hard to say whether any of these components have been changed. Some of the solder is quite shiny, but it doesn't, and looks a bit rough, so this cable might have been changed. It's really hard to say with something this old. A lot of the wires are all stuck to the chassis with some sort of glue. I don't know why they found that was necessary, so it's all brown now. Had a go at the tremolo, so that it obviously didn't think it was working at some time correctly. I've got the circuit diagram. I copied this off the back panel because I could not find online this circuit diagram. I found others that were different. So Ampeg obviously made quite a few variations of this amp, and this seems like a very, very early one. Later ones, circuit's been changed a bit, and they've even used solid state quite early on. This has got a valve rectifier, and they probably changed the valves as well. You can see it's got a 1, 2, 3, 4, 5, 6 sections of triodes and 2 power valves and a rectifier valve. So I'm going to check out this circuit. I have done a few tests already, and it is exactly identical inside to what's shown on here, so it's the right one. But I am going to check a few more of the resistors to make sure they're fine before I power it up. It's rather an unusual circuit design. The input's all fine and the tone control nice and simple, and it's got a sort of a paraphase splitter, which is almost normal, not quite. It's got a feedback from the output. That will reduce the gain a bit. I don't know if anyone ever disconnects that and sees if they get more or more power, or if that's, or better sound. I'm going to try it later just to see what it sounds like disconnected. Most early amps had feedback. It took quite a long time before guitar amp makers discovered you don't need a linear amp like hi-fi, and they started doing away with the feedback. Some people did, or put control in to adjust it. The tremolo, phase shift tremolo here is fairly normal until it gets to this part, which is connected to the input and varies the gain right on the input tube. Very unusual way of doing phase shifting. I don't know if I've ever seen that before. Normally the tremolo is done near the output, varying the power to the output valves or cutting the volume further down the circuit, not right at the input, by having a 47k 47k. By dropping that down to 0 and then back up again, it cuts the volume by half. Then when that's down, the input impedance goes way down as well to about 100k. Whether that affects your guitar a bit, we'll cut the bass slightly. Very unusual. Need to check out how that actually operates. Haven't seen it before, so that's a first for me. Let's look at the valves or tubes used in this old Ampeg Jet amp from early 65, maybe very late 64. You can see it takes 1, 2, 3, 4, 5 valves. Occasionally this one's not used in later amps with a solid state rectifier, but this one did. And they supply the circuit diagram on the back panel, and it lists the valves: 6BK11s, alternative 6C10, 7591s, and the 5Y3. Now the 5Y3 is straightforward double plate rectifier. This one you can see Sylvania, made in USA. I think that's still the original valve. The two output valves. Now they use these 7591s, exceptionally nice valves, not made anymore. Now when you see them, I've got them here. Not very large, they look like 6V6s. Now, how do you know they're 759s? Well, I took a photo of them and enlarged it for you so you can see it's written on there in case it doesn't come out. 7591, 7591A. Ampeg, made in USA for Ampeg, Sylvania. Fabulous valves. Why are they so good? Well, they got a very high gain. These valves got very high gain compared to this one. I can just show you on the graphs for the two valves, 7591 and the 6L6. Do you see? If you look at the grid voltage here, goes from 0 to -5. The difference in the current here, 100 milliamps. Plate has current swing for that, and then if you look at the 6L6, same current, same grid change, only 50 milliamps. So it's got half the gain or transconductance, whatever you want to call it. So fantastic two little valves. Don't look anything special, but they are. Those two valves are special, but even more special, the two input valves are triple triodes, not made anymore. And just look at this, how dumpy they are. Triple triodes. You can see the construction inside, three separate series of plates. Very expensive if you ever try to buy them. The 6C10 will work according to Ampeg. Apparently these are the best ones. Not sure if these are original, made in USA, National Electronics, and 6BK11, number 1. Expensive valves. Now another thing to note is that at the same time other manufacturers in the UK, for instance, were making similar amplifiers, but they didn't use these valves. They would have used EL84s in the output, and they would have used perhaps just a simple rectifier, which is it's something like EZ81, and all these, because there are 3 in here, all the valves used were generally just twin triodes, like ECC83s, to get the same number of stages. You would have needed 3 preamp valves to make 6 stages. And that would have been in an equivalent sort of UK amp, old amp. So in comparison, the valves in this amp are physically much larger. To an equivalent UK one, quite a difference. Now hopefully all these valves are, well, the original, still working okay, and these ones, 'cause even if you could buy them, apparently they cost a fortune now. These sort of valves are made in huge quantity and are still available quite easy. You can see the number of pins on the bottom. This has got 12 as opposed to 9. And these are big connections on the base pins. These are just regular small ones. Now I just noticed, looking at a chart of what valves you can buy, the 7591 is still listed by Electro Harmonics as being available. I don't know what it cost. Checking that the tension of these sockets is okay. Some of these valves, if you move them about, they crackle like anything. So you can, if you can't see in, you can use the correct size tool that should just be gripped as you push it in. These sockets, you work your way around, you should just grip and come out again. Now those are fine. Now these, I've had to use the correct size, a piece of wire. You can see, actually in these you can see the metal, little spring pieces of metal, but you have to make sure that it grips and comes back out again on each one. If there's one that's broken, bent out of shape, and this is just loose, falls out, you have to fix it. Next thing I'm going to do is remove the connection to this capacitor. It's this capacitor here on the circuit diagram. It connects to one side of the line into ground. Now because this amp is not earthed, so it'll be a 2-pin 2-wire, no earth, if that shorts, then it could connect the live or neutral to earth, the chassis, and could be danger of being electrocuted as there's no earth. Now these things can be converted to an earth normally. The wire, there's only a simple wire here coming from the fuse, so I'll just cut that off like so. Later on, when I'm testing the amp, I might remove this feedback resistor here, which comes from the speaker there, all the way back here, and it'd be worth just disconnecting it and checking the sound with it connected and without connected, see what the difference it makes. It's very easy to get to, and luckily, and remove and replace. Powering up the amp. I did clean the pots first with some of this, just in case they were noisy, just clean them out. I put the valves in and I've powered it up slowly on the Variac, just 103 volts at the moment. It's drawing 0.6 of an amp, so it's drawing over 50 watts. It's probably mostly the heaters. Now turn the lights off so you can see the heaters glowing. 1, 2, 3, 1, 2, 3. You see the heaters glowing in these. I've got a speaker connected up under the bench. There's a bit of a spitting noise coming, so there's obviously a bad connection, and I'm pretty sure it's still on this valve. I checked all the valve contacts and they were tight, but when you touch these valves, it's so noisy. And this one, the heaters didn't come on at first, they went up until I moved it. So I'm going to have to double check the pins on these things. These ones are fine. You just tap them. Turn the amp off so I can check these contacts on these valves. There's not much holding them in. They're very easy to move. These valves must be an aftermarket later valve that's been manufactured, and the pins must be undersized compared to the original ones, because these contacts are not bent out of shape in there. I did test them and they're tight, so these pins must be undersized. How to get around it? Well, there is one way. You can bend these pins very slightly so that when they go in, they push sideways on the contact. So I'm going to try doing that. Bend the pins very carefully and put a little sideways lean on them. Lean these ones to the left, and then I bent the other slightly to the right. And it should be nice and tight now. Feels much tighter. The valve does hang upside down, so any vibrations is going to shake this valve quite a lot, and it's not very heavy, but I mean the weight is trying to drop it out of the socket. After slightly bending the pins to get some good contact pressure, you can move this one now with no background noise, no crashing and banging. Same with this one. And the thumping, you've got thumping from the turn the tremolo up, turn the input up. Very low frequency thumping because it's working directly on the input here, fluctuating frequency up and down to cut the gain up and down to give you the tremolo. But that low frequency is being amplified through this valve. I'm assuming that was a design error, and they never, it probably was like that from new, and they would have changed the design later. No one really puts the tremolo right on the input valve. They do it later, right up here. But at least we know the tremolo is working from fast to slow. You can't, and then off. You can't adjust the depth, it's fixed, so it's just the speed. You could adjust the depth with a variable pot, say here, which is cutting the gain by half, 47k to 47k. If you made that bigger, you could reduce the tremolo. It's set like basically at maximum. I'll have a look at that. It might be possible. I mean, the gain here, this, you don't need a lot of bass through this. Maybe we can cut this capacitor here and cut the bass gain. At the input might cut that down a bit. It's interesting to note when I turn on this voltage here is the voltage off the rectifier, and it goes very high until these other valves start conducting. So I'll just turn it on. I've got it set to 110 volts on here, so just turn it on and you can see the voltage jumped up to 450 volts. That's a lot of volts, and 350 on the point C down here, so you have to make sure you don't exceed the voltage rating of capacitors while the valves are heating up. You see the voltage coming back down now, 340. It says it should be 340 according to the circuit diagram. We've got 109 volts in, so it's it will come down probably a little more. 11 volts across there. I'm not sure what that says. It looks like 15, so it's a bit low. Turn the controls. Not too bad. The tremolo is another thing I'm going to have to look at. It was thumping. Just turn it on. Turn the noise up there. Oh, now it's thumping. It thumps badly because it's fluctuating the input here at a low frequency, which is being amplified through this valve here. I don't know if it was like that when it was made or whether it started doing it. Because you turn the input. Well, at least at least you can tell the frequency. That's maximum and minimum. So we know it works anyway. Turn the volume down. It's just picking up noise. I've got the amp turned on, plugged in a Telecaster, just plug straight in, no effects. It's running at 110 volts input. I've got a couple of mods, but I'm going to show you, they're not switched in at the moment. One's for tremolo and one's for the feedback. I just want to show you the sound we've got now with the guitar plugged in. So I've turned the treble, the volume up. I'm going to turn the tone control right down just to show. Now that's full volume, but if I turn the treble up, makes a huge difference, a massive increase in volume. The tone control just cuts too much out. So if you want to cut the treble down, you only need to turn it down a little bit. The speed of the tremolo, these phase shift tremolos are pretty much fixed between a slow and high speed variation. You can't really get it very, very slow or very, very fast with valve. There's a potentiometer which varies the speed, but if you make it too big, the oscillations will stop. So it's all a bit of a compromise. You can make it slower or you can make it faster depending on what capacitors you fix. I'll just show you. This is the stock speed. That's as slow as it'll go, and as fast as it'll go. You can make it faster, which most people probably wouldn't want. You get slow speed, maybe not slow enough. So you can change. There are three capacitors basically in the phase shift. You can change just one of them can slow it down. I've got a capacitor here. Just switch it in. Made it very slow, but it knocks off the high speed. So you can fiddle around with the capacitor if you want and get either the slow speed or high speed, whatever you want, but most people probably use an external tremolo now anyway. The other thing is there's no depth on this, so you're fixed at that very... There are many ways of adding a depth control. This one doesn't have it. It also thumps badly at high volume. The way the circuit works, charging and discharging the capacitor, makes it thump. I can reduce that a little bit by changing the capacitor at the front end. It reduces the thumping quite a lot, and reduces the depth by about half, which I think is a bit better than I think that's too deep, but you can even reduce it further, but it's virtually nothing. But the trouble is, if you have it too shallow, then other sorts of sounds in D deep enough. You want it deep for that. So this whole circuit is a bit of a compromise. The only way to use the tremolo is you have to have the volume down, which reduces the thumping. So that's the tremolo, things you can do with it, but it's not really worth the effort. There's one other thing I'm going to do, is that's the feedback. The feedback resistor comes off the speaker back and cuts down the volume, as well as trying to make the amp a bit more linear, and it cuts the volume quite a lot. There's quite a severe amount of feedback. The amp goes pretty loud as it is, and they probably decided that the speaker probably couldn't take any more power that these valves can give out. But I'll just show you, you can actually replace that resistor with a potentiometer if you want. We've got one here wired up, and I'll just show you if I can play. You can make it really loud by turning the feedback off. Probably not coming out on the camera because it probably compresses it, but it makes a huge difference at higher volume, because you can get a really lot of overdrive through the amp with the feedback off. It does brighten up the sound. Now the tone control is very severe. Cuts virtually everything off, just leaving a muffled bass. So the tone control, normally I'd have it fully up. You could put this potentiometer somewhere on the back if you want and just adjust it. With the feedback on, you can always turn the guitar down. If you've got that amount of feedback, it increases the volume, everything, amazing. I'll try it again when I put the amp back in the cabinet with its original speaker. It's a nice sounding amp. I fitted a 3-core cable to replace the original 2-core one, which had no earth. I had to get a special one, US plug, because it goes to a 240 to 110 volt converter, but with an earth in it. And then I rewired plus and minus, plus earth goes to a chassis nut and bolt with a tag for the earth and a crinkle cut shake-proof washer. There's also a cable clamp on the chassis which secures the cable against being pulled if someone falls over it. The Ampeg jet finished. The only thing I've left to do, I'll take off the feedback switch that I've put on just to demonstrate, and I'll take it off. I've put a handle on it and cleaned it up best I can. So the feedback does, taking that off increases the output of the amp, the sensitivity, by at least twice. I didn't actually measure it, but it's very noticeable when you listen to it. And if you take the feedback off, much louder and brighter as well, and it becomes more and more driven the louder it's turned up. Now the tremolo, at low volumes on the volume on here, it doesn't thump through. I'll turn it on. You don't hear the thumping at all at lower volumes. Now that's, I haven't modified it to go slower, so that's the slow and the fast. and you can't adjust the depth, so it's quite pronounced. Personally, I think a better speaker I would prefer, but the speaker and sound is what you buy it for. Tone control. It's very muffled to very bright, and the volume increases hugely. So without this feedback mod, I would just have the tone control up full. Nice, clean, clear sound. Not a lot of bass, but who needs a lot of bass, I guess, for most guitar playing. Guitar just plugged in, and with the feedback taken off, massive increase in volume, and the treble, and that's only at part volume, right? Does give you an extra edge, but I mean, if that wasn't on it originally, so that's the way it goes. The feedback as it was designed, full volume. And with the feedback taken off, that's the amp. Nice little combo, sounds good, can get very distorted, and it can be quite clear at lower volumes. Tremolo, well, it's what it is, and fast. You can hear a bit of thumping to the speaker when you're not playing, but and that's it. I'll just take this off, put the back panel on, finished.